Lesson 5-7, Scatter Plots and Trend Lines. Alright, so in this lesson we're going to be getting away from our just writing equations. We still do a little bit of that, and we're going to learn how to make scatter plots. Alright, a scatter plot is a graph that relates two sets of data by displaying them as ordered pairs. Remember, ordered pairs are our x, y values. Most scatter plots are in the first quadrant. So if we have a coordinate plane, they're usually in this first quadrant because our x's are positive and our y's are positive. You can use scatter plots to find trends in data. So, below I have three examples of a scatter plot. The first one has a positive correlation. As you see, all the ordered pairs that are plotted kind of move from the bottom left up to the top right corner. This would indicate a positive correlation. The middle graph kind of starts in the top corner and goes down, kind of just like as if we had a negative slope. This is a negative correlation. Y tends to decrease as x increases. And over here, we call this no correlation. Our data and our ordered pairs are very sporadic and all over the graph, so there's really no correlation. We can't see a up or down effect. Alright, example 1 is making a scatter plot and describing its correlation. So this chart right here, they're always going to give you a data chart. The table below shows the altitude or height of an airplane and the temperature outside the plane. So whatever's first in our table is usually our x value, and whatever's second is usually our y. So altitude, as a plane gets higher, 0 feet, 500 feet, 1,000 feet, notice the temperature looks like, well, we're not really sure. Does it increase or does it decrease? We're going to use a scatter plot to tell. So, first step is simply just to make a scatter plot. Now, every x and y is like an ordered pair. So 0, 59 is what we would graph. But first, we need to label each axis and the increments we're going to go up by. Remember, we're going to use just this first quadrant. Altitude is my x value, so I'm going to say my x is my altitude, and up my y-axis is the temperature in degrees Fahrenheit. Alright, now I need to think about what I want to go up by on my x-axis. As you can see, my data points for x's are going up by 500. So if I start with 0, and this line is 500, 1,000, 1,500, 2,000, 2,500. I don't have a lot of room. And my y's are going up, well, we have anything from like almost 60 to 0. I think I'm just going to go up by tens. 20, 30, 40, 50, 60. Let's try that. So I'm plotting my points, looking at x and y. 0, 59. 0, 59. 559.2. 1,000, 61.3. 1,500, 55. 2,000 is 29, way down here. Oh, sorry, nope, 41. The next one, 3,000, is 29. 3,500 is 18, 26, 12.4, 0.6. All right, so I have my points plotted on my scatter plot. This is what the book shows, so mine is pretty similar, which is good. I labeled both my axes, showed you what my increments are, and plotted my points. Let's talk a little bit about the correlation before I go on. If you look at our graph, does it have a positive, negative, or no correlation? I would say for the most part our points go down, so I would say this graph has a negative correlation. When two sets of data have either a positive or negative correlation, you can use a trend line to show that correlation more clearly. A trend line is a line on a scatter plot drawn near the points. A trend line is something we do ourselves. Later on in this lesson, we talk about getting help from the calculator. That is a line of best fit. When we talk about trend line, that means we have a graph with a bunch of points, and we're going to actually draw in a trend line ourselves. You want to draw the line in the middle of the data. So sometimes it's kind of hard. Get a straight edge and try to find where you can touch as many points to draw that straight line. We can use this trend line, once we have an equation for it, to estimate data values that we don't know. So here we go. Writing an equation of a trend line. First, we need to make another scatter plot. So it looks like I have weight of a panda. The age is my x value, and its weight is my y. So age and weight. I would then, my increments of my x's go up by ones. 1, 2, 3, 4, 5, 6. I'm not numbering every line. And looks like my pounds, I could probably go up by 5s or 10s. Just for time's sake, I'm going to show you the graph already made. So there it is, age and weight, and they plotted the points. And then the second step that you want to do is you want to draw that trend line in once you have your points plotted. They tried to hit as many points as they could while keeping the line straight. Now, we need to actually come up with the equation of that line. What equation should we use if we know 2 points on a line? Well, first, I need to find 2 points. So you're going to go to your graph. Let's see if I can make this. No, I can't. Oh, it's locked. Okay. Anyway, you're going to find 2 really nice points on your graph. I'm going to pick this one and this one. So my coordinates are 6, 24. Now remember, you could have different points than someone else uses in your class. 6, 24, and this one is 10, 48. All right, 6, 24 and 10, 48. So to write an equation, we need to know the slope and we need to know a point. Well, I'm probably going to use point-slope form. First, I need to find the slope of my line, and I can do that with 2 points. Take my change in y's over change in x. 48 minus 24 over 10 minus 6. This is going to be 24 over 4, divide by 2, divide by 2 again, slope of 6. Now, using one of the points, it doesn't matter which one, y minus 24 equals the slope times x minus my x value. And then I always want my equation of a line to finally be in y equals mx plus b form. So I need to simplify. Y, add the 24 over, 6x minus 12. Here is the equation of my trend line. Now, even though you picked different points as maybe your neighbor does, your equation should be very close. It should have a very similar slope, if not the same, and your y-intercept should be very similar as well. Just going to check. All right. Now, this third example, finding the line of best fit, we're going to use our calculators for, so we are going to hold this example to do in class. Finally, the last thing we need to talk about is something called causation. Causation is when a change in one quantity changes or causes a change in a second. A correlation between quantities doesn't always imply there's causation. Here's an example, identifying whether relationships are causal. In the following situations, is there likely to be a correlation? And if so, does it reflect a causal relationship? All right, the number of loaves of bread baked and the amount of flour used. Well, think about it. If we make more and more loaves of bread, we'll probably use more flour. So there is indeed a positive correlation. As we bake more bread, the number of flour goes up. That's a positive correlation. It is a causal relationship also because the number of loaves we bake causes us to have more flour purchased and used. Example B. The number of mailboxes and the number of firefighters in a city. Well, if there's more firefighters in a city, there could be more mailboxes. It could have a positive correlation because both the number of mailboxes and the number of firefighters tend to increase as population increases. However, installing more mailboxes will not cause the number of firefighters in a town to increase, so there's no causal relationship. All right, all I'd like you to do for class is complete problems 1, 2, and 3 of the lesson check. You're making a scatter plot of the data, telling me what type of relationship there is, drawing a trend line, writing its equation, and using your equation, predict the average maximum daily temperature in January. You might need to go back in your books and look at problem 2 to see how we use our trend line to make a prediction.